So, on the beginning, there actually aren't any notes for you guys to write down, but I do need to explain everything that's down at the beginning where you normally write down all the definition stuff. I need to make sure that that gets explained. So we're dealing with variation. We've actually done direct variation in here before. Okay, we've done direct variation in here before. Direct variation, y varies directly as h. Direct variation, y and x are variables. K is your constant of variation. So for direct variation, you have essentially two forms of the equation. Y equals some number times x, or some number equals y divided by x. Sorry, x divided by y, direct variation. X divided by y. Okay. Is that right? No, it's y divided by x. Yes, thank you. It always takes me a second. Okay. So here's the deal. Every time I have a y value, if I divide it by an x value, I get the same number every time. That's direct variation. The idea is as one thing goes up, the other one goes up proportionally. That's direct variation. As one item goes up, the other one goes up the same amount. The change is proportional. Okay, and that same amount is what my constant of variation is. Okay, so as one thing increases, the other one increases. Your paycheck, how much money you make, is direct variation because you get paid by the hour. The more hours you work, the more money you make. That's direct variation. You work more money, you work more hours, you get more money. You work less hours, you get less money. That's a perfect example of direct variation. As one goes up, the other goes up proportionally. And that proportion is how much you get paid by the hour. Okay? Yeah, when I was your age, it was only like $3.85. And that was good money. I know, times have changed. Times have changed. So that's direct variation. Inverse variation is exactly the opposite. Inverse variation, y equals the constant of variation divided by x, or that constant equals y times x. If I multiply x and y together and I get the same number, that is indirect variation, or sorry, inverse variation. We keep always wanting to call it indirect. Inverse variation. Inverse variation. Inverse is one goes up, the other one goes down, proportionally. The best one I can think of is music. You're playing a guitar. You pluck a guitar string. The vibrations of that guitar string are where you get the sound. Okay, so you pick, like, say, the G string, and you pluck it. And it's going to vibrate at a particular rate. You put your finger on the fret to divide that string into half. So it's half as long. You pluck it again. It vibrates twice as fast. This gives it a higher pitch. The faster it vibrates, the higher the pitch. So it's directly proportional. The length shrinks by half, the vibrations double. It's proportional. Okay, it's proportional. And that's the way it works. That's the way it works. When you're playing the trombone, your length, you make it longer. When you make it longer, it ends up going a slower vibration. It's a deeper sound. Okay, music is a perfect example of inverse variation. Okay, so that's how that works. As one goes up, the other goes down. If I have a table, or if I have a set of x's and y's, and I multiply them and I get the same number, that is inverse variation. Not everything in the world is divided up between those two things. There are other kinds of relationships between x and y that are not direct or inverse, but those are the main ones we're dealing with today. So, the next one is joint variation. And joint variation is essentially direct variation with more than one variable. Okay. That's what joint variation is. Joint variation is direct variation with more than one variable. Y varies jointly with X and Z. That means my constant of proportionality is equal to X times Z. So it's jointly, so it's directly with both of those variables that it's jointly with. It could be jointly with like 5 or 6 variables. Jointly is another version of direct variation. If I were to simplify it down, the constant of variation is equal to Y divided by X and Z, the variables it varies jointly with. Jointly is direct variation with more than one variable involved. And it varies directly with more than one variable. And then you get combined variation, which is both of them.
No.
Okay, it's inverse and directly. Okay, so you get combined variation. Is jointly and directly both. So you can compare more than one or two things. You can compare more than two things. Direct variation and inverse variation only compare 2 items at a time. They either both go up or they go in opposite directions. Both go up, both go down, or go in opposite directions. With joint and combined variation, you've got several different variables in context that are working together. And as one changes, the other 2 change accordingly. Okay, but if it's proportionality, it does that. In chemistry/physics, I can't remember, I think it's the ideal gas law. I'm not sure what it is. You have temperature, pressure, and volume. Is that ideal gas law? Yes, I remembered it correctly. Oh my God, because it's been ages since I've done it. But ideal gas law is that if you have pressure and volume and temperature vary, and it's a combined situation. If one stays constant, the other 2 are proportional. Okay, and it's a combined variation with those 3 variables. Okay, that's essentially what the ideal gas law is. It's this. Okay. So when you're dealing with it, and there's 2 examples that I have here in your notes. Y varies directly as X and inversely as Z. Oh, directly, that means Y divided by X, and Y inversely Y times Z. Directly as B and C and inversely as D, that means it's directly with B and C, and inversely as D. This relationship right here, this one, and this one, and this one, are going to be what you're going to use to solve 90% of your problems. And the stuff that we're doing today, and then combined, remember combined is going to be this and this together. Part of the reason I wrote them up on the boards is so I have them in front of me while I'm doing the notes. Okay. You will have to have memorized which ones means which. Okay. But the idea is we're going to set up relationships to solve. That's what 90% of what we're going to be doing is going to be related to. Yes?
Like testing out like different sets of
Finding, yeah, you're going to have this varies directly with that. If I have this value, if I have these 2 values and this value, what's the next one? And you're going to be finding the missing part. And we did that with direct variation. We did that with direct variation several chapters ago. Now we're adding in all the other ones with it. And we did direct variation a long time ago. Now we're adding in a bunch of other stuff with it. Okay, so your first examples. determine if the variables are direct, inverse, or neither. Okay. If they are direct variation, then when I take y and divide it by x, I get the same number each time.
Oh.
So for direct variation, if I take y and divide it by x, I get the same number each time. Okay, so 1 divided by 0.25 divided by 1, that's 0.25. 0.05 divided by 5 is not 0.25, it's 0.01. I divide them here, I get 0.25 for the first one, 0.01 for the second one. I'm done with direct variation because all I need is one time it doesn't work and I stop. But I have to work for all of them. So if these two first ones came out good, I would have to keep going to check all 4 of them. But once I get something that doesn't work, I can stop. I don't need to worry about the rest. But if they do work, I need to make sure they all work. So this is not direct variation. Okay? Direct would be y divided by x being the same. That's no good on this one. So now I need to try inverse. Inverse is where I take x times y. I multiply the 2. Do I get the same thing every time? 1 times 0.25 is 0.25. 5 times 0.05 is 0.25. 10 times 0.025 is 0.25. So far it's looking good, but it needs to work on the last one as well, or I can't count it.
Oh, okay.
25 times 0.01 is 0.25. This is inverse variation. So it's inverse. And my constant of variation is 0.25. The number I got when I multiplied them all. And if that wasn't constant, it would be neither. You got 3 choices. It's direct, it's inverse, or it's none of the above. Divide them all, see if that works first. Multiply them all, see if that works. If neither one of them work, it's neither, and I'm good.
Wait,
Okay.
they both work?
No, it's one or the other. Or neither. Okay, so I want to do the same thing on this one. So I want to say, all right, let's take a look at this. I'm looking at it and I'm thinking division will work just fine on this one, just glancing at the numbers. So that's what I want to check. I want to check y divided by x. Negative 15 divided by negative 3, that's 5. 25 divided by 5, that's 5. 30 divided by 6, yep, that's 5. 80 divided by 16, that's 5. This one is direct. And when I took y and divided it by x, what did I get each time? I got 5. That's my constant of variation. Okay? So direct, you divide. Inverse, you multiply. And then these tables aren't going to work for the joint maker line. That's a whole set of different problems. Okay? Because then you'd have to have 3 variables, and you'd have to work out with 3 variables, and I'm not going to do that to you. Yes. Okay. Because I could set it up with a table, but I'd have to be a 3 variable table. I'm not that mean. Okay. Your turn. Check those. Okay. So I like to test direct first just because it's the first thing on my list. So I divide them out. So I check y divided by 6, y divided by x. 6 divided by 2 is 3. 15 divided by 5 is 3. It's looking good, but no guarantees. 24 divided by 8, looking real good. 33 divided by 11, okay, we got it. It's direct. And my constant is 3. So that one's, like I said, it starts out pretty nice. It's actually not too bad. Same thing this way. Y divided by x. 4 divided by 2 is 2. 9 divided by 3 is 3. It doesn't work. So then I try x times y, and I get 8, and I get 27. And that's no bueno either, so it's neither. I can just stop it too, and I'm done, because once it doesn't work, it doesn't work. One bad apple does spoil a whole bunch. Okay? Actually, that is true in real life, because what happens is, if you have a bunch of apples in a bag or a barrel or something like that in storage, and one of the apples starts to spoil, what happens is that apple gives off a particular gas. That spoilage gives off a particular gas, which will cause the other apples that are grouped with it in storage to spoil.
That makes sense.
Isn't it just a mold?
It's not mold. It's not mold. It's not a mold. It's not moldiness. Mold will do that, but literally, if you have an apple that gets bruised, and that bruise starts to cause that to go soft and spoil, it gives off a gas. It gives off it's like a sulfuric gas that will cause the rest of them to spoil. So yes, one bad apple. The Jacksons got it wrong. One bad apple does spoil the whole bunch.
Who's the Jackson?
You know the Jackson 5, that was one of their songs. One bad apple doesn't spoil the whole bunch. Well, they were wrong. It does. So they paid more attention in school. They learned things like that. Yeah, I know. There's some famous. Well, actually, not so much. I mean, Cheeto's not all that, you know. Okay. Janet's doing okay. And Rich and Fame, how did that work out for Michael in the end? Not real great, because nobody ever told him no. Okay, so here we go. Okay, guys, focus. Let's get this going. Direct variation. Y varies directly as H. Write a function that models each direct variation. So Y varies directly as H means that Y divided by X is equal to Y divided by X is equal to Y divided by X is equal to Y divided by X in perpetuity.
What? Oh.
In perpetuity, forever and ever.
I see what you're talking about now.
Okay, so you picked up a vocab word in your math class. Let's see if you pick up some math in your English class. Okay, so Y divided by X is the same value every single time. That's what direct variation means. So here's what I do, is I take and I set up an equation using the Y's and X's given to me. Okay, X is 9 when Y is 3. So using these two here, 3 over 9 is equal to something I don't know over 12. Something I don't know over 12. And I solved that. I don't care. There are lots of ways to solve these equations. There are tons of ways to solve these equations we're going to be working with today. This one here, I would just multiply both sides by 12. Strictly because I have the variable divided, Y divided by 12, multiply both sides by 12, because it's one step. It's easy. Okay? You multiply both steps by 12. Those cancel, and you get Y equals. And then let's see, I can cross cancel and oops.
That's it.
I can reduce, right? 9, that goes 3 and 1 there. Ooh, that one cancels there to give me 4. So Y equals 4. Not that big a deal. Okay. It'll work. Okay. No, it was 3. I crossed it out. Yeah.
That's crazy.
Okay. So, next one, same thing. Y over X equals Y over X. 5 over 2 equals Y over 12. Solve it. Now, for me, like I said, I'm just going to multiply both sides by 12. However, something that will also work every single time, I have a proportion that means I have a fraction equal to a fraction. You can cross multiply and set up that equation. That's what you want to do that. Cross multiply. 2 times y equals 5 times 12. Cross multiply. That will always work. Divide both sides by 2. Y equals 30. Okay. There's lots of ways to solve these. I'm going to be dead honest with you. I'm looking for 2 things. I'm looking for the setup equation, and I'm looking for the final answer to go with it. That's what I'm looking for. I'm looking for the setup. I'm looking for the answer. Because there's more than one way to solve this proportion. There's more than one way to do it. And I really don't care as long as you do it using good math to get the correct answer. Yes, that's on recording. I don't care as long as you do good math to get the answer. But you better give me the setup and the answer both. Okay? Like I said, there's lots of ways to do it. Lots and lots of ways to do those. Your turn. Okay. So, direct variation, that means y divided by x equals y divided by x, etc., etc., etc. I like to set up that equation first before I start doing the problem. That will come in handy, not so much with the inverse, direct and the inverse, but when you get to the joint and the combine, setting up that proportionality before you get started will really make things easier for you. But I'd like to do it anyways, even with this, so I don't screw it up. Okay? So, x is x and 18. So I have 18 over x equals 9 over 3. Okay, well, I can figure this one out lots of different ways. I can cross multiply, I can do all that stuff, but here's another thing I can do. What is 9 divided by 3 if I reduce that? 18 over x is equal to 3 over 1. What do I multiply 3 by to get 18? 6. So what I need to multiply 1 by to get 8x? 6. I multiply both of them by 6. What do I get? I get x equals 6. You can reason it out using logic. I know. I'm really pushing on that one. But like I said, I don't have to cross multiply. If I can recognize that. You got the setup, you got the answer. I'm okay with it because, like I said, there's lots of ways to do these. Okay. Next one, same thing. 18 over x is equal to 5 over 20. I'm going to do the same thing on this one. Or I could cross multiply, but why not? Here's the other thing. I can always reduce. If I can reduce ahead of time. If I'm doing it this way, what is 5 over 20? That's 1/4, right? 1/4 is a lot easier to deal with than 5 over 20. Because here, even if I cross multiply, that makes cross multiplying easy. X times 1 is x. 18 times 4 is, let's see, 40 plus 32 is 72. Cross multiply with a smaller fraction. Why not reduce and make the number smaller and thus easier to work with? Smaller numbers are always easier to work with. Okay. Inversely. Inverse variation. That means x times x is equal to y times x is equal to y times x is equal to y times x in perpetuity. So, find y when x is 3. So y times 3 is equal to x times 3. 9 times 3. 9 times 3. Something times 3 is equal to 9 times 3. What is that something I'm multiplying times 3? Come on. I mean, literally. It's like, I have 2 things I'm multiplying times 3. One of them is 9. What's the other one got to be if there's the same thing? It's got to be 9, right? Okay. Same thing here. X times y. So 3 times y is equal to x times y. 2 times 5, which is 10. Uh-oh. But Mr. Orris, it doesn't go into it evenly. Yeah, and? So you got a fraction for an answer. Who cares? You got a fraction of a fraction. Who cares? You got the right answer. 10 over 3.
Appreciate it.
Okay? So inverse, direct and inverse are really easy on their own. Direct, you divide x and y. Inverse, you multiply the two. Inverse is even easier. Your turn, do those. Okay, these aren't that bad. They shouldn't take too long. So I'm multiplying, remember, it's y times x. Y times x. That's what you have. So I have y times x. So I'm going to get 4y equals x times y here. 6 times 2 is 12. 4y equals 12. So y equals 3. Same thing here. 4y equals 5 times 4. That's 20. Y equals 5. Inverse and direct, really not hard. You're either dividing the two numbers or you're multiplying the two numbers. You have to remember which one's which. Now it gets a little hairier. Okay? So joint variation is another version of direct variation. But I'm varying directly with more than one variable. So y varies y varies jointly with x and z. So that means it's direct variation with both of them. Direct variation is y divided by x. Here it's y divided by x and z. So I get y over x and z is equal to y over x times z. That is my relationship. It is important to set up that relationship based on the information before you try to solve anything. If you can get that relationship between x, y, and z or whatever variables you're given, it makes everything else easy because then you're just plugging in the numbers. And you have two sets here. First one, find y when x is 4 and z is 5. That means y over 4 times 5 is equal to, yes.
Should we write 4 times 5 or 2?
You can make it 20 if you want to, but when I do it up here, I'm going to make sure it's y, x, and z. Does that make sense? So I've got my three variables. So I have y is 20, x is 2, and z is 5. 20 over 2 times 5. So all I did on this first step is actually just plug in the numbers in where they belong, so you can see where they belong. Now you start to simplify a little bit. Okay. Y over 20 is equal to 20 over 10. Really? Okay. Let's see. So that means y over 20 is equal to 2 over 1. So what's y? 40. Okay. Y equals 40. No, you can't because it's equal, so you can't cross cancel that way. If you're when you're multiplying, you cross cancel. But I'm not multiplying, right? They're equal to each other. I know. I say the words fractions, and half of you faint, the other half your eyes just roll back in your head, right? Yeah, let's be honest. I know how fractions work. Okay. So same setup on the next one. First half is still the same on this particular problem. So I have y over 4 times 5 is equal to 30 over 3 times 4. And then I want to try to clean it up. Y over 20 is equal to 30 over 12. And then I can reduce the 30 over 12. If you can reduce, I like to reduce because if I can make the smaller numbers, they're easy to work with. 30 over 12, 6 goes into those. Gives me 5 over 2. So y over 20 equals 5 over 2. What do I multiply 2 by to get 20? So I multiply 5 by 10 to get 50. And like I said, if you want to cross multiply at that point and then solve for y, I'm okay with that. Right? Do what you need to do to solve it. I need to see the setup. I need to see the answer. There's more than one way to do this. And the more complicated the numbers, the more complicated the problems are, but you can always cross multiply with nothing else. Always. Okay. And remember, the key to doing this problem is setting it up first. Setting up the relationship between y and x and z. Okay. Your turn, do that one. Okay. Y varies jointly as x and z, so once again, it's y over x times z equals y over x times z. And then I set it up. So I have my first situation, which is the same for both of them. Y over 3 times 5 equals, in this case, 36 over 1 times 6. 36 over 1 times 6. So y over 15 is equal to 6 over 1. So I multiply 6 times 15, and you get y equals 60 plus 30, 90. Relationship is the same on the next one. I still have y over 3 times 5 equals 15 over 2 times 5 here. So I get y over 15 is equal to, my 5's cancel, I get 3 over 2. And I would just multiply both sides by 15 or cross multiply in this one. 3 times 15 is 45. So y equals 45 over 2. I would much prefer this, but if you gave me the correct decimal, I'd be okay. Yeah, 22.5. Okay. Ooh, y varies jointly. Jointly directly with x and inversely with z. So, jointly means both directly and inversely. And the nice thing is it tells you, ooh, directly with x. Directly means divide. And then inversely, that means times. So I have y divided by x and times z. That's my relationship between x, y, and z. Direct means I divide, inverse means I multiply. If you remember those two things, okay, so that means y over x and x times z, so y over 8 and times 4 is equal to 6 divided by 9 times 3 up here. That's my relationship. Y and z get multiplied divided by x. So this reduces, so I get y over 2 equals, and this reduces 2 as well. 6 times 3 is 18 divided by 9 is 2. Y over 2 equals 2. So y equals 4. What's half of 4 is 2? Yeah. Multiply both sides, whatever. Y equals 4. I do the same setup here. The initial setup is the same. Y times 4 over 8. Y times 4 over 8 is equal to 5 times 6 over 10. So that gives me y over 2 is equal to 5 times 6 is 30 divided by 10 is 3. So y in this case is 6. Once again, the key is setting up from the first line of information, what's the relationship between those variables? If I have two variables, that's easy. It's either divided or multiplied. If I have 3 or 4 or 5 or 6 variables, anything that's direct is dividing, anything that's inverse is multiplying. That's your setup. And, ooh, it's your turn again. I talked you. Okay, so here we go. Y varies directly with x and inversely with z. Do you remember? Divide, multiply. So y times z divided by x. Those are the relationships of my three variables. And so I have this one here. It's y times z divided by x is equal to y times z divided by x. So y over 2 is equal to 4 over 3. Multiply both sides by 2. Y equals 8/3. Same relationship here. Y times 2 over 4 is equal to 7 times 10 divided by 5. So that means y over 2 is equal to 14. 7 times 10 divided by 5 is 14. Multiply both sides by 2. Y equals 28. Piece of cake. Easy. Ooh! The ideal gas law.
That's not the same.
Okay, the volume of gas varies inversely as its pressure. So I guess temperature is being held constant in this particular case.
STP.
ST.
Standard pressure.
Okay. Gas varies inversely as pressure. So inversely means that gas and pressure are going to be multiplied. P and V. P times V equals P times V equals P times V. Inversely means multiplication. P and V for volume. V times P equals V times P. That's my relationship.
Oh, I see.
And then you just plug them in. Volume is 80 cubic centimeters. Pressure is 2,000 millimeters of mercury. I'm not going to worry about the freaking units. So 80 times 2,000 is equal to V times 320. Divide both sides by 320. Okay, well, 80 times 2, 1, 2, 3, divided by 320, and it works out to be 500. And that would be cubic centimeters or milliliters. Same thing.
That's my least favorite thing.
Easy peasy. Figure out the relationship. Once you figure out the relationship, it's easy after that. I love, these are my favorite types of word problems, are ones like this. Because you're only comparing a couple of things, and it's always the same comparison every time. Your turn. Okay, so I have direct variation. Direct variation means I divide them. Direct variation, ooh, that's division. And I have S and F. So S divided by F. So if a spring stretches 20 inches with 25 pounds attached, so that's the first one. And the second one, so 20 over 25 equals, how far will it stretch? The S we don't know, divided by 15. Multiply both sides by 15, cross multiply, however you want to do it. And you get 12. Like I said, I love these word problems. You're going to have two variables. All you have to do is figure out, am I multiplying the two variables or am I dividing the two variables? Is it direct or is it inverse? And you need to learn the rule between inverse and direct. You have to have that relationship between them memorized by the time we get around to taking the test on chapter 8. Okay? Questions?